Oh wow, it's 4 a.m. and Sarah and Isaac are studying all night long. They are disrupting their circadian rhythm, which is a natural internal process that regulates the sleep wake cycle and repeats every 24 hours. It is often referred to the body's internal clock and is influenced by external cues like light and darkness, which help synchronize it with the day and night cycle. It's not only responsible for regulating sleep patterns, but also various physiological processes such as hormone production, body temperature, metabolism, and cognitive function.
We have now entered my brain, specifically the SCN, or the suprachiasmatic nucleus. The SCN is a part of the hypothalamus above the optic chiasm. It tells us when we should be tired and when we shouldn't. It is the main driver of rhythms for sleep. The light resets the SCN through the retinohypothalamic path. Input goes to the retina, then to the bipolar cells, to the ganglion cells, then to the optic nerve. It reaches the SCN, and then to the pineal gland, which then releases melatonin.
Wow, it's 5:30 in the morning and all this blue light has been keeping me up all night and I'm really tired and I want to go to sleep. I think I'm going to take this melatonin. So what is melatonin and where is it released from?
So, melatonin is released from the pineal gland and it's usually released at night to help you sleep. And it also helps with the control of the onset of puberty.
Wow, the puberty part is really cool, however, that probably wouldn't help me at this point.
In order to record the stages of sleep, we have to use a polysomnograph, which is a combination of EEG and eye movement records.
Okay, class. So this is an EEG recording during sleep, and it's broken up into four different stages of sleep, including the stage 1, stage 2, stage 3, and the REM stage. Starting off with the first stage, stage 1 is known to have irregular, jagged, and low voltage waves, where the brain activity tends to decrease and lasts for about 10 to 12 minutes and uses alpha waves at around 8 to 12 hertz. You move into stage 2. Stage 2 is characterized by the presence of sleep spindles and K complexes and shows higher amplitude and lower frequency waves. Stage 3, also known as the slow wave sleep stage, shows slow and large amplitudes that take over, which slow the heart rate and breathing rate and overall brain activity. It uses a larger amplitude and holds a lower frequency and incorporates delta waves. Finally, REM sleep is characterized by the use of light and deep sleep characteristics. Yes, Sarah?
So is Isaac in stage 1 of sleep? The 3 major functions of sleep. Number 1, resets your muscles. I hope I get adequate sleep so my muscles aren't super sore tomorrow. Number 2, it reorganizes your synapses, which is important for overall cognitive functioning and for your learning. Number 3, it strengthens your memory, which is why it is important for you to get good, adequate sleep before an exam.
There are several sleep disorders that can affect an individual's ability to obtain restful and sufficient sleep. For example, narcolepsy is a neurological disorder characterized by excessive daytime sleepiness and uncontrollable episodes of falling asleep during the day. Insomnia is a common sleep disorder, and symptoms may include trouble with falling asleep, staying asleep, or getting overall good quality sleep. A night terror is an experience of intense anxiety from which a person awakens screaming in terror.
No!
Another sleep disorder, also known as sleep apnea, can be described as the impaired ability to breathe while sleeping, which can also result in a lot of snoring, as you can see.
Sleep paralysis is the inability to move while falling asleep or waking up. Many people have experienced sleep paralysis occasionally, but people with narcolepsy experience it more frequently.
We have now entered the locus coeruleus part of my brain, located right there in the pons. Its axons release norepinephrine to influence wakefulness in different areas of the cortex.
In conclusion, sleep is important.